Unit Circle by Madeleine Nolte. Okay. So, here's the whole unit circle. On the unit circle, it is mapped out sort of like a coordinate plane. So you have your y-axis and your x-axis right here. On the unit circle, you have 4 different quadrants. So you start off with quadrant 1 up here, quadrant 2 over here, quadrant 3 down here, and quadrant 4 right here. So you have, on top of your quadrants, you also have radians, and the 4 main radians are 0 to pi. Then 90 degrees later, you have pi over 2. Then 90 degrees later, you have pi. Then another 90 degrees, you have 3 pi over 2. So those are your basic radians, but you also have a lot of other ones, but they go in a pattern. So you start here, pi over 6, and every 30 degrees you have a multiple of pi over 6. So if you go from pi over 6, you go 30 degrees, and this is 2 pi over 6, which simplifies to pi over 3. Then another 30, then you have 3 pi over 6, which simplifies to pi over 2. 4 pi over 6, which simplifies to 2 pi over 3. Then another 30 to 5 pi over 6, which cannot be simplified. Then another 30 to 6 pi over 6, which simplifies to just plain pi. 7 pi over 6, which can't be simplified. Then you have 8 pi over 6, which simplifies to 4 pi over 3. Then you have 9 pi over 6, which simplifies to 3 pi over 2. Then you have 10 pi over 6, which simplifies to 5 pi over 3. And then 11 pi over 6, which can't be simplified. So that's for all the pi's over 6's. But then you also have pi over 4 every 45 degrees. So you start here at pi over 4. Then this is 2 pi over 4, which simplifies to pi over 2. Then you have 3 pi over 4, which can't be simplified. 4 pi over 4, which in turn equals just pi. 5 pi over 4, which can't be simplified. 6 pi over 4, which simplifies to 3 pi over 2. 7 pi over 4, which can't be simplified. So that is all your radians. But you also have coordinates. So the coordinates sort of go in a pattern. So you start here, and the coordinate for 2 pi is 1, 0. Then you go up here, and your coordinate is 0, 1. Over here, it's negative 1, 0. And down here, it's 0, negative 1. So those are your coordinates for the main radians. But the smaller radians have a pattern. And the pattern is, for here, it is square root of 3 over 2 and 1/2. 1 over the square root of 2 and 1 over the square root of 2. And 1/2 and the square root of 3 over 2. So that is for this side. And if you come over to this side, on a graph, your x's are negative on this quadrant, but your y's are positive, so this shows up in the coordinates. So the pattern basically repeats itself from this side. It's just the same pattern, but except this time your x's will be negative because that's how they are on the graph. So you start here, and you have negative 1/2 square root of 3 over 2, negative 1 over square root of 2, and 1 over the square root of 2, and negative square root of 3 over 2 and 1 over 2. So these two, the patterns go the same, with the only difference being that x is negative. But if you come down to this quadrant, quadrant 3, the pattern actually reverses itself. So that's kind of tricky, but it's not too hard to remember. Also, the x and the y are negative on this side, so both of your coordinates, your x and your y and your coordinate, are both going to have to be negative. So since the pattern reverses, you don't end with square root of 3 over 2, comma 1/2, you start with it. So here at 7 pi over 6, you have negative square root of 3 over 2 and negative 1/2. And then negative 1 over the square root of 2, negative 1 over the square root of 2. And negative 1/2, comma negative square root of 3 over 2. So basically, that's that side. Then the pattern repeats itself from the quadrant 3 and quadrant 4. Except for in quadrant 4, only your y is negative and your x is positive. So that's going to reflect again in the coordinates, as you can see, with 1/2 and negative square root of 3 over 2. Then 1 over square root of 2, and then negative 1 over square root of 2, and square root of 3 over 2, and negative 1/2. So that is your coordinates, but you also have tangents. So this is the last really important part. On your 4 main coordinates, your tangent here is 0. Then across on the x-axis all the way over to pi, your tangent is also 0. And then at your top y value, your tangent is undefined. And then all the way down, your tangent is also undefined right here. So that's the 4 main ones. But if you go over to your pi over 6's and all of that, your tangent here is 1 over square root of 3. At pi over 4, it is 1. And at pi over 3, it is square root of 3. So just like before, quadrant 1 and quadrant 2 follow basically the same pattern. Except for in quadrant 2, your tangents are going to be negative. So here at 2 pi over 3, your tangent is negative 3. Here it is negative 1, and here it is negative 1 over square root of 3. Now just like before, the quadrant 3 and quadrant 4 go in the opposite way of tangent 1 and 2. So here, all of these values are going to be positive, and you start with square root of 1 over 3, or 1 over square root of 3 instead of ending with it. So that's that. And then at 5 pi over 4, you have tangent of 1. And then at 4 pi over 3, you have a tangent of square root of 3. So over here, it follows the same pattern as quadrant 3, except for all of these tangents are going to be negative. So you have negative square root of 3, negative 1, and negative 1 square root of 3. So that is all your tangents. And an important thing that I forgot to mention at the beginning is when you're doing the unit circle, you go counterclockwise for all of them. Kind of forgot that, but that's okay. And the last important part to remember is your reference angles and the equations that you do to find them. So for quadrant 1, your reference angle equation is reference angle of theta is equal to theta. For quadrant 2, your reference angle of theta is equal to pi minus theta. And here in the third quadrant, your reference angle of theta is equal to theta minus pi. And your fourth quadrant, your reference angle of theta is equal to 2 pi minus theta. So now that you've learned everything, that's the unit circle. Yay!